Okay, a while ago I made a video on how to find the square roots of I, and that video right now has over 190,000 views. I'm really happy about it, and thank you guys so much for that. Unfortunately though, since I only did it with algebra, some people didn't like it too much because I wasn't using sine cosine and the polar form of a complex number. But the deal is, imagine if I was showing sine cosine to somebody who have never seen them before, such as an algebra student. What will happen? That's no good, right? So that was the purpose for that video. It was just for the algebra students. We will do it algebraically, as said in that video, right? But anyway, today we'll do the polar way, okay? But with that being said, we have to do some prep work. First of all, to find the square roots of I, we know we are going to get complex numbers. So as a reminder, we know I can write z as a, just call this to be a complex number, z. We can write this into the standard form, a plus bi. And let me just show you guys on the complex plane, okay? So here we have the real, and here is the imaginary. And a plus bi is like, a is here and then b is here, maybe. And then we have this point on the complex plane, and that's the complex number a plus bi. And the deal is that if you can find the angle from here to here, and then the r from here to here, this is the r, this is the angle, you can change this into the polar form. And to write the polar form, the x value, right? This is technically the x-axis, that kind of thing. So you associate with cosine theta. So the a, namely on the x-axis, right, as usual, you can look at this as r cosine theta. And then the b is the y value, so you use sine for that. So we can write this down as plus. I will write down the I first, and then the r, and then sine theta, like that. This is the so-called polar form of a complex number, and now let's focus on this. Anyway, right here, this is our original complex number z, right? Let's take a look on what if we square this. So let me put down z square, okay? What happens? I'm not going to look at this anymore because some people don't like it. I'm going to look at this. So I will just square this, okay? So let me put this down. We will have r. And I can factor the r, as you guys can see. So I will put on the r in the front, parentheses, cosine theta plus I sine theta, like this. This was the z. And then I will have to square this, okay? And now, to square this, of course, we can just square the r and square this. And you can also quote some theorem, but let me show you guys more detail. First of all, this is just r inside, but then cosine theta plus I sine theta, by Euler's formula, we can write that down as e to the I theta, isn't it? And then let's square this. And the moment you square this is the exponential form, so we can just multiply 2 with this. So in another word, we will see this is just r squared, and then we will have e, let me put down the I, and then the 2 theta, like this, because we multiply the powers. In another word, take a look. R squared is just r squared as expected, but instead of the theta as the original input, we will have 2 theta for the input, right? So we will actually have cosine of 2 theta plus I sine of 2 theta, like this. And can you imagine what if we cube both sides? Yes, we will just triple the angles, right? So we have 3 theta inside and 3 theta inside. And the idea is that geometrically speaking, here is z. When you square z, you pretty much just rotate the angle, right? Instead of theta, you rotate it again, so you have to put on another theta. So all in all, you will have 2 theta, like that. And depends on what r is, you also have to square r. So, if r is bigger than 1, it's longer right here. If r is less than 1, it's going to be smaller, and that kind of thing. But, you guys hopefully get the idea, like that. So suppose r is bigger than 1 right here. Suppose r is bigger than 1, okay? Then you have this being longer somewhere, okay? And the nice part is, if r is exactly equal to 1, suppose if r is equal to 1, then we will still be on the circle. So I'll just draw a circle like this for you guys. if r is equal to 1. In fact, it's the unit circle. That would be nice. R squared will still be 1. And this is going to be z squared. And then z cubed and so on. And just keep going. So this explains why when we square a complex number, you just kind of turn. When you cube a complex number, you just turn. Right? It's like dancing. Anyway, let's work on this. We are going to find all the square roots of I. This is what we want now, okay? We want z such that, okay, I'll just put on such that z squared is equal to I. This is what we're looking for, right? The square root of I. I want to have z to a second power to be I. This is the deal. And what can we do? Well, we know z is equal to r cosine theta and plus I r sine theta, all that, right? So I will leave that to you guys because let's take a look of what do we want to end up. Here is the picture. Z squared is equal to I. So let's take a look of the complex plane again. Here is the real and here is the imaginary. I want to get to I. So let me just put on I being right here. And you know the distance from here to here is just 1, right? Because this is 0 plus 1i. So if you would like, you can put down a unit circle nicely right here. And that's nice because when r is 1, that's nice. Anyway, okay, now the deal is that I want to find z so that when I turn, I will end up with I. That's what it is, okay? And what can we do? Notice that from here to here is 90 degrees. And yes, I'm using degrees. Why not? 90 degrees for now. You can use radians, doesn't really matter, okay? And of course, turn of each time is the same angle. If you divide it by 2, 90 divided by 2, you get 45 degrees. So you can imagine, oh, by the way, r is 1. So let me just put on r is equal to 1 to be legitimate. 45 degrees is right here. So this is the angle. This point on this unit circle on the complex plane, it will be one of the z's, okay? Okay, so our goal is to find out what this is. On the other hand though, do we have another answer for this? Can we think about an angle so when we turn, we'll end up with this point I? Well, I used 90 degrees already. 90 degrees divided by 2 is 45 degrees. So that seems pretty much it. But don't forget, 90 degrees, we can also look at this as what? You can add 360 to that. Namely, we can also get 450 degrees. And if you do 450 degrees divided by 2, this will give us 225 degrees, isn't it? And that's exactly this right here. If you just extend this right here, it's just on the other side. Like that, this is 225 degrees. This is also another complex number, so when we turn, we will end up with I. That's the deal. And if you are talking about just from 0 to 360, these are the only two. And the deal is that when you have z squared is equal to whatever, like I, you have two solutions, and then we have these two solutions already. So that's pretty much it. Now, as I said, because r is equal to 1, so it's just 1 and 1. We know z is going to be just cosine theta plus I sine theta. 45 degrees is the first one, 225 is the second one, so you pretty much have the answers. But anyway, let me write this down for you guys to be legitimate. Z is equal to cosine of 45 degrees. This is the first one. I know this is pi over 4, okay? Plus, I is I, and then we have sine of 45 degrees. And you can work this out real quick. Cosine of 45 degrees is 1 over square root of 2. And sine of 45 degrees is also 1 over square root of 2. And let me put that down first. And of course, we don't have to rationalize the denominators if you don't want to. But don't forget to put on the idle. This is the first square root of I. And the second one, I will write it down here. Z is equal to, with a blue marker for the angle, cosine of 225 degrees plus I times sine of 225 degrees. And now this is seriously just a nice reflection here and here. The x and y value both become the negative version of that, right? So we have z equal to negative 1 over square root of 2 minus 1 over square root of 2, and put the I right here. Okay? So here is the first answer. Here is the second answer. Okay, which one do you guys like more? Of course, this is way cooler than the algebra way, but as I said, I cannot show any algebra students with like sine cosine in the first place, right? So that's why I did it with the algebra way last time. But anyway, hopefully you guys all like this. And if you're new to my channel, please subscribe and maybe tell other people about my channel as well. Thank you guys so much, and as always, that's it.